what goes into the neural net up here, this is kind of representing how you could also have audio. Okay, so what this is representing is like you could potentially send an image to this neural net, or this is representing, like, pretend that you had typed the words MOE models are, and it's showing it kind of going through this algorithm and predicting the next word would be incredible. MOE models are incredible. All right, so, but yeah, you could also put an image in. Like, how can you even do that? And the answer is through embeddings. Embeddings are a way of taking one domain, like words or pixels, and mapping it into a higher dimensional, like, meaning space. What this means is that similar concepts share an embedding, even though they may be represented as, like, different inputs. And so what that means is, like, the word big and the word large, they may be written using completely different letters, but they mean a similar thing. And what an embedding model would do is take the word big, and it would take the word, and these are the letters, take the letters that make up the word large, and when it transforms it into an embedding, the result is going to be almost the same for both of those two completely separate inputs. They're different on the surface, but the meaning of big and large is actually the same. And the reason that's useful in any way in this this kind of algorithm is that the neural net cannot read pixels. It cannot read letters. It has to be, somehow the input has to be represented as a matrix. And yeah, technically, I guess, like, a picture is technically a matrix, but that's actually not exactly what it's doing in this case. But for the neural net to be able to do math with it, it has to be represented as a matrix. And so this embedding layer, the net effect of it is that something kind of fuzzy, some domain like text or images, the fuzzy thing goes into the embedding model, and what comes out of it is the embeddings representation of whatever that thing was that went into it. And in this way, you could relate, or you could represent similar ideas in images and in words. And when you have a model that is trained on kind of like an embedding model that's capable of dealing with multiple modalities of input, now all of a sudden your language model can do reasoning on images. And in this case too, Gemma 4, like these two tiny models over here, they also support audio. And oh, actually here, you know, actually this is pretty good representation down here of the. It'd be kind of nice to show this with words too, I guess. But fundamentally, no matter if it's pictures or sound or like letters and words, all of these modes of input, they just need to be turned into something that you can math. And that's fundamentally what an embedding model does. You give it something, and it gives you a vector representation of it, and you can just run with it. And just it's like an aside from all of that. On one of my side projects, what I'm using embeddings to find relatedness between documents. Because you can also take a whole document with lots of words and extract the embeddings from that and project it into an embedding space. And if you have lots of documents projected into this embedding space, related documents are going to be close to each other. And so I'm thinking of this as an alternative to like tags and categories, because it's like a naturally emerging grouping. And so now I'm grouping by embeddings.